Hello everyone, this is Ms. Shaista Khanum. Today we are going to understand image processing fundamentals. So, how the image is taken, how the image is processed using Python, and how it is represented, and what are the different types of images. So, first of all, when you capture an image, while capturing an image, see, normally you know that we buy a camera of some megapixel. So, what is pixel in that? Pixel is nothing but a smaller part of our image. The smallest box, see, actually, I can say this is nothing but an image. So, if I take this image, so image is nothing but divided into these small boxes. These small boxes are nothing but called as pixel. So, one smallest box is nothing but one pixel. Now, when you take the image, so image is divided into rows and pixels. So it is nothing but image is nothing but an array of a matrix of a pixel arranged in columns and rows. And each pixel represents some value. Now, what value it represents? It represents nothing but what is the color of that what it is representing. That pixel is representing what. Now, based on a type of image, right? Based on a type of image, what we are representing, the pixel values are changing. Now here it is showing something 254. So I can say this is nothing but my grayscale image. Now basically we are going to see grayscale image, binary image, and color image. Now if I see grayscale image is nothing but a image which is nothing but having a shades of gray. So over here you can see this is nothing but a grayscale image. So this is a color image, and grayscale image is nothing but there is no color in that. It is nothing but having a shade of uh, gray, and the darkest possible shade is black, and the lightest possible shade is white. So all the range of the pixel values which is represented in an image is nothing but 0 to 255. So that means one pixel value is nothing but representing a number which is ranging from 0 to 255. So 0 represent the white color, and the 255 represent the black color. So any value in between is nothing but representing its shade. Now, so I hope this is clear that image is nothing but a matrix which is consisting of rows and columns. So this is nothing but first row, second row. So I can if I want to process this image, so this is nothing but I have to process this matrix by using its rows and column. Now next we see binary image. What is binary image? This you can see binary image is basically, as the name indicate, binary is 2, 1 or 0, right? So that means in binary image we have only two color, black or white. So you can see this is a color image, and this is nothing but a binary image. So here we are representing all the like light colors with the zero, that is nothing but what, white, and all the dark colors with black. So this is nothing but what, how we are. So in this image, like if I'll see every pixel, so all the pixel values will either have 0 or 1. So that is nothing but what, a binary image. So one pixel value represent either 0 or 1. So I can say if I want to represent a pixel in for binary image, then the pixel value minimum I need only 1 bit, because I need to represent only 0 or 1. Whether if I'll consider a grayscale image, in grayscale image, if I'll consider, so in grayscale image I'm representing a shade of gray. So that is nothing but what, 255 shades. So that is nothing but what I can represent with 8 bits. So one pixel value is nothing but 8 bit. Now if I consider a color image, now here is nothing but what, you can see this is nothing but a grayscale image, and here this 15, 14, 13 and 12, this is nothing but what, it's each pixel value is represented over here. So this is nothing but what, how the matrix is represented. Now if I consider a color image, so color normally we can consider a RGB color scheme. So in RGB color scheme we can say that any color is made up of RGB, red, green and blue components. So how much component of R, G and B is required to form this color? So based on that you have so we need 8 bit for each color. 8-bit for each color. So red component 8-bit, blue component 8-bit, and G component 8-bit. So based on how much combination of that is required to form this color will be decided based on that color. So this is if I consider 1 pixel, then in this 1 pixel, this 1 pixel will be represented by 24-bit. That is nothing but 8-bit for each color. So 24-bit is required for the color image. So this is nothing but what we have seen, a very basic fundamental of binary image, grayscale image, and color scheme, color image. So now we'll see how we can read this image and we can get the grayscale or the binary image using Python. So first of all, I've used a Google Colab. So normally the library which is required for for using for image processing is nothing but OpenCV. So this is nothing but what import.cv2 is nothing but what I have imported the OpenCV library. Now next is very important, import numpy as np. Numpy is a Python package which is basically used for array operations. So as we know that, see, basically CV2, the OpenCV library works along with NumPy. Without NumPy, it is not going to work, because as we know that image is nothing but an array, and we are going to work on the image using array format only, like used based on rows and columns. So NumPy library is by default. So this import NumPy and CV2 is two default libraries which we need while operating for image processing. Now import matplotlib is nothing but matplotlib is a Python package which is used for plotting the images. So next, if we will see, first is nothing but I have imported all the packages. Then after that, I have read the image. I'm using Google Colab. So here I have uploaded the image. Now next is nothing but plt.imread. So here what I'm doing, I'm reading the image, right? So this is nothing but what my image. So I'm reading this image, and after reading this image, you can see plt.imread, and after reading this image, I'm keeping it in img. See, img is nothing but my array. It is nothing but what, a matrix representation of my image. So here you can see I have printed this img. So you can see this is nothing but what, a matrix. So this matrix, each value, right, each value is nothing but what, it is representing a pixel value. Now next is very important, I want to show you that print image shape, right? What is print image shape? Image shape is nothing but what, it will find out that how many rows are there, how many columns are there, and what is the channel. Now, so here in a first row, I'm printing the rows of the pixel, column of the pixel, and color channels. So here you can see when I'm printing shape. So in printing shape, it is showing 1803. What is 1000? 1000 is number of rows, 800 is number of columns, and 3 is nothing but, as I'm taking a color image, so there are three components. So it is nothing but what, three channels, RGB, right? Three channels are there, and individually also I'm printing. Now next you can see here I'm giving, see, I'm doing two things. I'm giving a title to my image, and I'm printing this image. So this is nothing but plt.title. Using matplotlib, I'm giving a title, and I'm displaying the image. So you can see here this input image is shown, and this is nothing but a image which I have read it. Now next is nothing but, if I want to show it, like I want to show image like original image and the binary image or grayscale image. So I can represent it I can divide the display into rows and columns also. So here you can see for that command is plt.subplot. Here 211, 2 is nothing but what, 2 is nothing but number of rows, and 2 is nothing but how many columns are there. 1 is nothing but number of rows, and 1 is nothing but what, my first image or second image. So in 2 columns and 1 rows, I can display 2 images. So plt.im show, here I'm displaying my image. Now next, very important part, I'm converting this image. This is a color image. I'm converting this color image into grayscale image. For converting into gray, so first part is nothing but I'm taking a original image. Here you can see this is nothing but what I've plotted a original image 211, and next is nothing but what plt dot subplot 212. So second row, two this is nothing but what there are two columns, first one row and second image. So this is nothing but what here I'll get in a second part. So sorry, this is nothing but what first is nothing but number of rows, and then this is column, because here you can see I'm showing two rows, right? So these are two rows for one column and first image. So two second, this is nothing but 211 and this is 212. Now next I'm converting this image into grayscale image. For converting into this, first of all I'm separating the RGB component, and then using this formula I'm converting the RGB image into grayscale image, and then I'm showing it. So I hope it is clear that this is nothing but what a grayscale image. This is nothing but a color image, and this is nothing but a grayscale image. Now, so this is nothing but what how we can show, how we can do this image reading and displaying, how we can see the shape, and how we can convert it into this thing, converting into grayscale image. Now, one of the problem in Google Colab I have faced, like you can check, like some of the commands of the open series are not working over here. It is disabled. So for that, I have used ideally also. So here you can see, here I'm using import CV to import numpy, and after that I'm reading the image, and this is nothing but what I'm showing them. Secondly, what I'm doing, now this is very important part. Here, see, here I'm converting the image into grayscale and then converting the image into black and white image. That is nothing but a binary image. Now, in this grayscale image, so in CV2 we have a very good command, like we can convert the image into grayscale image. Now, for that, first of all, see here, this is nothing but what CV2. Uh, For grayscale image, first of all, what I'm doing here, I'm using a function cv2 to color underscore bgr to gray. This is nothing but what I'm, see, first of all, when you read the image, like in cv2 they are using a color format as blue, green and red. So blue, green and red, so bgr to gray. So this is nothing but a function which is used to convert the our color image into grayscale image. So directly by using this one line of command, I can get the gray image. And after this gray image, here I am showing this gray image. Next, a very simple one line command for converting it into threshold binary image. Now I have converted the gray image. Now what I'm doing, I'm taking gray image as an input. I'm using CV2 to threshold. What is thresholding? Thresholding, what we are doing in grayscale, what we are keeping it, like all the pixels which are having value from 0 to 127 will be mapped to 0, and all the values above 120, from 128, that is above 127, 128 to 255 will be mapped to 1. So in this way we are converting all the pixels value which are 0 to 127 to 0, and 120 and 128 to 255 into 1. So that is nothing but what we are getting only two levels, black and white, that is 0 and 1. So with the help of this threshold command, I'm converting the grayscale image into binary image, and here I'm showing the image. So I'm running this program, and I'm in a video link I'm sharing the codes also. So you can see this is nothing but what, first of all, this is my color image. Okay, now after this is my black and white image, and then this is my, sorry, I'm very sorry, this is nothing but my grayscale image, and this is nothing but what, my black and white image. So I hope you got some idea about the image processing. uh, simple image reading, displaying and converting into grayscale and binary image. So thank you so much.